Okay, so today our plan is to go through our problem of the week. Uh, it actually pertains very nicely to what we're doing right now with ratios. Then we'll go over the assignment, and after we've corrected that, we'll talk a little bit more about some percents and some applications of them. So first thing is our problem of the week. We've got, as we read through this the first time, we can see that we're talking about somebody who went to both Japan and Australia. And as she's going on to the two countries, she changes her US dollars for Japanese yen, and then later wants to convert her leftover yen into Australian dollars. And we know the conversion between US dollars and Australian dollars in both cases. So as you read through the problem and identify the essential information, the big things we need to see here is that she has this much yen left, and that many yen are worth $1, and $1 is also worth this many Australian dollars. So by what in geometry is called the transitive property, or in other words, this idea of both of these two things equal to the same thing, therefore they must be equal to each other, we know that every 105.5 yen must be equal to 1.63 Australian dollars. And our essential question here that we're trying to answer is how many Australian dollars is this amount of yen worth? So knowing what we know about proportions, we know that we can take her amount of yen and compare that to the amount of Australian dollars, and we should be able to write a proportion for this. So we know the conversion here is that every 105.5 yen is equal to 1.63 Australian dollars. And since she currently has 10,500 yen, we can write this proportion to figure out how many Australian dollars that is the same as. And now using what we know about solving proportions, we can cross multiply. 1.63 times 10,500 is going to equal 105.5 times x. And to solve this problem then, we will simply take both sides of our equation, divide by the coefficient of x, 105.5, and with some quick calculations on our calculator, we can come up with the value then for x, which is her number of Australian dollars. Notice when we do the calculations, we end up finding that x is 162.23 when we round, and we want to label that with Australian dollars. Okay, so that was our problem. And now we move on to our lesson. Again, keep in mind that you have a benchmark coming up on Friday, and you should all have these sheets that explain to you what it is you need to do. Yesterday's lesson went into the specifics of how to do percent problems and what a commission was and how to find one quantity as a percent of another. Today we're specifically looking at sale price as well as sales tax and tip. So yesterday's assignment on page 118, these are the answers. If you need to take some time to check this, pause the video, look over your answers, and anything that you're unsure how to do, watch some extra videos or come in and ask a math teacher for some help. Here are the answers for page 130 and 135. Again, if you're struggling with anything, come in and ask for some help. Okay, talking about sale prices here, we have a Samsung Galaxy tablet, which is normally priced at $399.99 and is on sale for $349.99, and it says you're saving $50. The question here is, what percent are you saving? Oftentimes advertisements are listed in terms of percent savings. In order to figure out the percent savings, we're asking literally the amount that you save is what percent of the original price. So when we set up our proportion equivalent to the percent ratio, we need to make sure that the percent saved equates with the dollars saved, which is this $50 here. And the 100%, which is the whole, equates to the original price, which is the $399.99. So we're going to put 50 over $399.99 and set that equal to X over 100. And by going through and doing the cross products, so multiplying diagonally across the equals, we can find the value then of X after we divide by this coefficient of $399.99 on each side. And if you take your calculator and divide that out, you should find that you get about 12.5% as your percent savings. Now let's go a step further. Let's say we had the same percent savings as we did on the Samsung for the iPad here. So we're talking again a 12.5% savings is what I'm referring to, the same percent saved, not the same dollar amount saved. And the question is, how much would this iPad cost me? So since the iPad normally costs us $499.99, we can figure out the dollars saved, again setting up the same proportion of 12.5% over 100. Because the 12.5% is the percent saved, what I'm going to calculate here is the dollars that I save. This will not directly tell me how much it will cost me. This is simply going to tell me how much I save. When I go through and calculate this amount, again using cross products to figure this out, I can figure out that X, the dollars that I saved, would be equal to $62.50. This amount saved doesn't actually tell me how much I owe or how much I'll pay. I need to first take the dollar amount that it costs and subtract from that the savings, and then I can determine what I'll actually end up paying. And when we do that, we end up getting a final cost of $437.49. Now there is a more direct way to get to this answer. If instead of determining how much I save, I instead go directly at how much I pay, I can get this answer immediately. So this is what I mean. Our original price still $499.99, and our original percent still 100%. But now I want to look at the percent that I pay. So if I saved 12.5% and the whole amount is 100%, when I subtract that, what I'm left with is the percent that I paid. And so I end up finding out that I'm going to end up paying 87.5%. If I use that amount right here, then what I determine for my value of X actually gets me directly to the dollars that I'll pay. So that's a much more efficient way to solve these problems. It also allows us to solve problems where we know the final price and we know the percent that we saved, but we don't know what we started with. And the only way to calculate what we started with is to be talking about a percent that we paid. Because if we don't know the dollars that we saved, the percent that we saved isn't going to help. Okay, talking about savings plans. When we talk about simple interest, that means that it's getting paid on your initial investment only, not on money that's been deposited later. So it's getting paid only on the initial investment, which we call a principal amount, and it gets paid at the end of each year. So if we invest $765 and we want to know how much is paid at the end of 1 year, we simply take $765 and we calculate 3.5% of it. Remember, to do that, I'm going to take the 3.5 out of 100 multiplied by that amount. First finding 1% by dividing by 100, and then finding 3.5 of those by multiplying by the 3.5. If you do this, you end up with about $26.78 when you round it. Again, keep in mind these calculations can be done if we simply take our decimal here divided by 100 and just take the 765 multiplied by 0.035. Now, if you keep your money in for more than 1 year, each year you get paid this same amount, or approximately that same amount. Remember, this was a rounded amount. So if we want to figure out how much we'll get at the end of 4 years, we're going to do the same calculation to find the 3.5% from 1 year, but then we're going to take that answer and we're going to multiply it by 4. In other words, we're taking that principal investment, multiplying it by the interest rate that we're getting paid, and then multiplying that by the amount of years, or the time in years, that that money is going to be accruing interest. And that actually gets us what's called the simple interest formula, which is shown down here at the bottom. That to figure out your interest amount, I, we take the deposit amount, P, which is called principal, multiplied by your annual rate, converted into a decimal, so divided by 100, times your number of years, which is your time. If your time is given to you in terms of months, for example, if it says 9 months, remember that T has to be put in as a number of years, and so we put it in as 9/12, or 3/4 of a year. Anyway, for our answer up here, at the end of 4 years, we would have $107.10 of interest paid to us. If we were asking how much total money you will have, not how much you've been paid, but how much you'll have, we would have to add this to the amount we invested so we can find our final balance. All right, commission again. We talked a little bit about commission yesterday, but many people who are paid by commission are actually paid based upon not just the commission that they earn. My pens are not working for me right now. Paid not just based on the commission that they earn, but they're also paid a fixed dollar amount per year or per month. So in this case, we've got a commission that's being paid like a bonus plus a fixed amount. So every single year, Karen is guaranteed that she's going to get at least $28,600. Plus, she's going to get this bonus of 4.25% of her sales. And so when we want to do this, just like before, if we want to find a percent of something, we take that percent and we convert it to its decimal value by dividing by 100, so 0.0425. And then we multiply that. That's how much we get for every dollar. Out of every 100 cents, you get 4.25 cents. So we get that much for every dollar, multiplied by the number of dollars of sales. This right here will calculate the commission dollars. This is paid in addition to the $28,600 that's been guaranteed to her. So when we do the calculations there, then we can determine that the commission amount was $13,175 added to the guaranteed pay gets us a total pay for the year of $41,775. Interest earned and interest owed are calculated the same way. So again, notice here it says simple interest, and we're trying to find the total amount owed after 6 months, which is half of 1 year. So since the annual interest rate is 8.5% and the initial amount borrowed was $900, we know that to figure out the interest, we're going to take what you started with. We want to find 8.5% of that, so 0.085, and that's going to happen each year. We only have it in for half a year, so our time here is 0.5, rate and principal. When we multiply these together, we can determine that the total amount owed would be $938.25. We know this because when you actually do the calculations here, this is going to calculate for you not that total amount, but rather the amount of interest that is owed. So this is the amount of interest that is owed. In order to figure out the total amount that you'll owe, total owed, we have to add that to the amount of the loan because you do have to pay back that loan as well. So putting those two amounts together tell us how much total you'll owe now. This problem is a little bit different. It's asking us for the amount of time that it's going to take for this much money invested to earn this much interest. So we're telling what we started with, which is that principal amount, and we're being told the annual interest rate of 6%. So we know that our rate here is 6%. But what we don't know is the amount of time or the amount of years that it's going to take. We do know that we want this total amount here to come out to be equal to $324. So by doing some of the calculations here, the 1200 times the 0.06, we can figure out that on this side I get $72. Essentially, this is now saying that you will get $72 each year. And the question is, how many years does it take before you've accumulated $324? So dividing both sides by the coefficient of t, $72, I can determine that the total amount of time that would take would be 4.5, and that's a number of years. So I would say that this would take 4.5 years to accumulate that much money based simply on simple interest. Now, as far as tips and tax, they're done the exact same way. If I want a 15% tip on this check, I'm simply going to calculate what 15% of $42.65 is. If I want to know the amount of tax, and the tax is a 5.25% tax rate, then I'm going to take that amount in its decimal form, so divide it by 100, and multiply that by the cost of the stereo to figure out the amount of the tax on the stereo. Notice these problems are asking us to estimate though. So while this will get us an exact value, an estimate is a little bit easier to come up with. We're going to round this to about $43. And to find 15% is actually pretty easy. 10% of something is just simply 10 out of 100, or 1/10 of that item. So 43 times by 1/10 or divided by 10 is 4.3. That is 10%. Now 5% is simply half of 10%. So I'm going to cut this in half. And I know that 4 cut in half is 2. And 3/10 cut in half would be 15 hundredths. This is like 30 hundredths. And so half of that would be 15 hundredths. So if I add these together, then I'll get the approximate amount of the tip, which would be $6.45. Similar idea down here, I'm going to do some estimating. So I know that this is approximately $200, and I know that 5% is just half of 10%. So I'm going to start by doing 10%. Remember, that means 10 out of 100, or 1/10 of that amount. If I take 200 and divide it by 10, I will get $20. So that's 10%. That means that 5% is half of that, or $10. We want 5.25%, which means it's going to be a little bit more than $10. Now, one way that I could know for sure, I could actually get down to 1% if I divide this by 5. 1% would be $2, just dividing by 5. Again, I'm taking each of these pieces that I know, and I'm thinking about their relationships. 5% is half of 10%. 1% is 1/5 of 5%. So 6% would be $12. 5% would be $10. So 5.25% would be somewhere around $10.50. That would be a pretty good estimate of the amount of tax that you would pay on this almost $200 stereo. Okay, so you should have gone through and gotten enough information to help you understand these problems. If there's anything that confused you, just remember you can rewind, go back and rewatch the videos.